Consider this language: a power n, b power m, c power n plus m, and n comma m is at least 1, which means we find a b c c or a b followed by this and so on. So we should ensure when we read a corresponding C is read. When we read a B, a corresponding C is read. Only then we can ensure this match. What am I saying? This can be rewritten as a power n, b power m, c power n, c power m. This is equivalent to writing a power n, b power m. Let me write c power m followed by c power n. Means these two are associated and these two are associated. And we know how to write a grammar for this, how to write a grammar for this. So simply plug in that over here. So let's start from S, and let's say S imply A, S, C, and with this you can pump AC any number of times. And now I want to switch and then start generating this. Okay, so what I do, either you can say S imply this must be ensured. So what I do, after this I need to generate this. So let me say B, S, C. But if I do this, what will happen? You can even start from here because start symbol is same. Correct? So you can even start from here and then you may start generating BSC. But that is not part of the language. So what I should do is I should not do this when I want to switch. So S imply ASC. Now when I want to switch, I use a different symbol. So I say S implies A, capital A followed by C. Fine. Now A implies B, A, C. With A you can pump this BC pattern any number of times, and we should ensure we get at least one B, one C. So we say S imply A imply BC. So remember, I should not use this. Otherwise, what will happen? I may start a string starting from B, but this says at least one A should be there. Okay, so such a thing is not allowed. Fine. Similarly, can I say this S imply ASC, and when I want to switch, I use S imply A, and then I say A imply BAC. Here again, instead of starting here, you start from this and then take this. Then what will happen? You may end up generating a string having B as the first symbol. So even this one is not correct. Fine. Now let's look at this production rules. With this, let's look at a sample string. Suppose I want ABCC, then I'll start from here. S imply A, capital AC, then A imply BC. Fine. Now if you want something like triple A, double B, 5C, then I start from this. S imply A, S, C, and again A, S, C. Now at this point in time, I want to switch. So let me take A, capital A, C, C. So now what is that we have done? For this, we need 3 C's. Yes, that's taken care. Now I need to use A to take care of this. So triple A followed by, for this I write BAC, and then I'll replace this A with BC. Fine. So now this clearly tells you that you can come up with a unique derivation for a string, and starting from this symbol or starting from this symbol, the string that is generated by this language certainly follow this pattern. Okay. So now when do you say a string is part of the language? Starting from S, we come up with a sequence. So we say alpha 1, then alpha 1 is changed to alpha 2, then alpha 3. So what are this? Alpha I is a string over this. So at the end, you get a string W, and what is W? W belongs to terminal star. Okay, it could be epsilon or it could be some string over terminals, which means this W is part of the language. So starting from S, and you get say alpha 1 or alpha 1, and so this is my alpha 1, then it is changed to alpha 2, then it is changed to alpha 3, and so on. Finally I get a W, which is a string over terminals, which is part of the language. So the strings accepted by PDA and strings generated by this grammar, they are all one and the same, which means this grammar is equivalent to the PDA or this language, A power n, B power m, C power n plus c. Okay, this is one. And another thing is, one should avoid something like this. Let me say S imply ASC and S imply AAC and A implies BAC and say A implies epsilon. Okay, now let's see whether this one and this one are equivalent. Now I need ABCC. Let's try generating using this. So I'll start with S implies AAC, and ideally I should choose this followed by this, but it may so happen that I may choose this as well, right? Now you have two choices, either you can take this or this. Supposing I take this, then what you get is AC, but the AC is not part of this. Okay, so a grammar like this, although it accepts this, but in addition to that, it also accepts something more, certain strings which are not part of the language. So grammar must be sound and complete, which means strings generated by this, precisely this set, and every string that is present in this set must be generated using this. So it should not generate a string which is not part of the language. So it generates every string that are part of this. In addition to that, it also generates some invalid strings which is not allowed. Okay, so ensure that when we write productions, such things are taken care. Okay, so in particular, when you use epsilon, one has to be careful. Similarly, when you say S implies epsilon, then epsilon is part of the language, but epsilon is not part of the language. If epsilon is part of the language, then one can have a production like S imply epsilon, otherwise one should not have. It may be of use when you supply that and you get to see AC pattern followed by BC, but it also generates certain strings, for example epsilon itself, which is not part of the language. Okay, so pay attention when we use epsilon, and it might generate strings that are not part of the language. Consider this language WWR, and W is a string over A comma B, and WR is precisely the reverse of W, which means A is valid, even epsilon is valid, BB is valid, AB BA is valid, ABB A followed by ABB A is valid. So now then AB BA, now it is AAB, then BAA. Now if you look at these things, you can extract a pattern. The pattern is the following: this B and this B is associated, this and this is associated, this and this is associated. Now look at this and this is associated, this and this and this. Now it clearly tells you that when you generate a corresponding A is generated at the end. When you generate a B, a corresponding B is generated. So now this clearly tells you ASA or BSB, and now S can be epsilon as well. Yes. Now you see, if you look at this, the start production itself is taking us to epsilon, and epsilon is part of the language, which is why I am using this. And these couple of strings, they tell us that A corresponding A, B a corresponding B, and you can pump this any number of times. Fine. Now the other language which is related to this is WCWR, and this is acting as a switch. Now the simplest string is C, because if W and W are epsilon, then it is C. Otherwise it is ACA or BCB or some string like ABCBA. Now the pattern that we saw for this and this are one and the same, except that the switch. So instead of epsilon, simply say this. So S implies C is allowed. Otherwise, you start with A and ensure a corresponding A is also generated. Or when you generate a B, ensure that corresponding B is also generated. So with this, you get to generate WWR, and the middle symbol is C, which you get using this. And if these two are epsilon, you generate just this, so that is also taken care. Okay, so now one can see that context free grammars are quite powerful, and a finite set of rules, simple and elegant, representing an infinite set. And interestingly, that infinite set is also accepted by pushdown automaton. So now, as far as pushdown automaton is concerned, you can come up with a transition function or a transition diagram, or something like context free grammar. But for PDA, there is no expression similar to regular expression can be expressed using some algebraic operation. The class of language is accepted by PDA. No, that is not there. And similarly, from a transition diagram, we may not be able to get a context free grammar. For a regular grammar, one can obtain from finite automaton, because this transition diagram or transition function, they involve stack symbol. So one may not be able to map that to context free grammar. Instead, we focus on the underlying set, and with that we observe a pattern like this, then derive a recursive formula, and with that we are able to see soundness and completeness. Okay.